So, without further ado, the state of web exploit toolkits.
Yeah, so first off, I just want to thank everyone for coming to the last talk on the last day of Blackhat. So it's quite a few more people than I expected. A little bit nervous, but. So I'm going to be talking about the state of web exploit toolkits, which is a lot of what I've been doing my job. And I am the lead for our advanced security intelligence team at HPDB Labs. And so a lot of what my job is to deal with malware, analyze it, try to figure out ways to determine reputation. We do a lot of malicious content harvesting, and so with something like web exploit toolkits that are becoming more popular, more prevalent in the wild, it's something that popped up on my radar, and it's been becoming a very interesting topic for me to to continue researching. And so if you're not familiar with them, web exploit toolkits are prepackaged software that generally consists of an installer. A lot of them are PHP based, and they have a database backend. It's normally MySQL. They include a large number of exploits, and most of these exploits actually target known vulnerabilities that are already patched, and they're rarely zero-day. There is one instance of a zero-day vulnerability being in these things. And another interesting and important thing with some of the we can actually get some of these PHP files in raw form, but they're actually using the IonQ PHP encoder, which encrypts the PHP file, and so it's difficult to recover. There are services out there that they claim to be able to decrypt these this encoding, but I've never found any that actually really work. And a lot of these also have fancy control panels where you can go through and they'll show statistics on, statistics will be about what countries are your visitors coming from, what browsers are they using, what exploits have been launched and successful. And so and you end up getting quite a bit of information from that. And then also you can configure which exploits you want to use and which, and which payloads you actually want to also launch. And so it ends up being very similar to a normal web application. And where they differ is where, their whole goal is to install a malicious payload, some piece of malware. It's been used a lot to build up botnets, Trojans, and fake AV, ransomware type stuff. And so it ends up being, at the end of the day, it's just a easy way for any cyber criminal to easily build something up and make money. And so a lot of these kits, they can cost thousands of dollars. Some of them are free, but some of them are very expensive. You can also do rentals, and the rentals, it's daily, monthly, weekly type stuff. And so they actually do like a similar model of maybe a day costs $100, but then for a week it costs $500. So it's like, to get you up to that next level, they'll offer you a discount to try to get you to go up. And so then they also do bulletproof hosting, which is hosting on their hosting servers where you're not going to get taken down by any kind of stuff because it's hosted by cyber criminals, so they're not going to obey law enforcement's requests to remove it. And a lot of times they'll contain agreements for like EULAs, where it's like, you have permission to do this with our kit, you cannot resell it, you cannot disclose what's in it, you cannot, just kind of, it's like what you expect to see with normal software. And that's where it becomes really interesting because it's functions, the economy is built up like a legitimate software business, but in the underground. So it gets really interesting because there's marketing and competitiveness between kits where where like one kit will say, we're better than this kit because we have exploits A, B, and C, and another kit will say, well, they stole those from us, and so it's just like the whole back and forth between these guys. And the other way that they mimic normal software is They do a lot of bug fixes. They do reliability updates for exploits if people complain. And they also do aesthetic changes. I've seen kits, you know, when a new version comes out, they're like, oh, we added a new spinner into our control panel, or we made this statistics look nicer. And so it ends up being, you know, very interesting just from that perspective. Of they actually, you know, it's there's like a feedback loop between them and their customers. So this is an image that I borrowed from HackersSecurity's blog, who talks a lot about these things, and who's definitely been someone who, like, if I kind of am stuck on something, I'm trying to find something new, trying to verify a trend. Yeah, he's one of the guys who's definitely been a big help. And so he's talking about, you know, a lot of the active kits that are out there. So it's like I'm going to talk about Black Hole a lot, and then Phoenix. Then you also see in the older kits like Eleanor, Bleeding Life. And you also see Red Kit, which I don't cover, but actually has some, like, I believe it has some bytecode obfuscation. It's Java exploits. So it's just like, you know, some other interesting features that are coming around in these kits. And so the typical way that these kits work is, you know, so you see the red exploit kit server. They're going to normally they'll try to go out and find a vulnerable website. They'll attempt to compromise it, inject their malicious JavaScript that ends up redirecting any potential visitor to their site to this other site, and then, you know, they'll do the typical browser detection, see if you're running if they have an exploit for whichever browser version you're running, to see if you have if you're running any plugins that they may have an exploit for, and if they detect it, then they will attempt to exploit you, and if they exploit you, then, you know, they will end up loading their malware, and then you can actually go into these. You can also go into the control panel on this kit, and you'll actually see a list of everyone who you've currently compromised, and so then you can also manage them from there. Yeah, so the first kit I'm really going to dive into is Black Hole, and you know, it's been around, hasn't even been around for a couple of years. It's, you know, almost 2 years now. It's definitely become the most popular kit on the market, and I'm basing a lot of that on what I've seen on using sites like Malware Domain List, URL Query, and also our malicious, like all the samples we collect from other places. We're actually seeing lots and lots of instances of this kit versus other kits. And so I believe the last version was 1.2.3. They may have just recently updated it because they did just add a few new exploits. And a lot of the exploits that they've been using have been you know, targeting Java vulnerabilities. And I'll get into that a little bit more, I guess, in a couple of slides. And then they also, so at the time there was a Microsoft XML vulnerability that was discovered in June. That was, at the time it was 0 day. It was being actively exploited. You know, researchers were able to find copies of this page that were in the wild and you know, actively targeting people. And so we're like, you know, people were posting about this, and the kit authors also saw this, and they took these pages and they adapted them and got them into their kit. And so they were actually able to get it into Black Hole while it was still in patch, and it was patched a few weeks ago. So thankfully, it's you know, there's protection out there for it. And one of the biggest things that Black Hole does is JavaScript obfuscation. So they constantly change it and tweak it a little bit just to try to just stay one step ahead. And you know, so we've actually done a lot of running URLs that we find through our sandbox and watching the results, watching the behavior of how it makes URL requests, which exploits are loaded. And you know, you know, at the end of the day, it doesn't do anything super sophisticated, but they do enough sophistication to try to stay one step ahead. And so this is just a slide with, these were news stories from 2011 that of black hole, it was in the news a lot. So in mid-May of 2011, they made a version free while they still kept their the newer versions paid. So there's like here's a sample. If you like this, come back to us and buy the full version. And they also had were able to compromise the United States Postal Service and redirect a lot of visitors there to versions of their kit. And they also did the same thing with MySQL.com. And then they also have done, they're doing lots of spam campaigns these days, trying to install various versions of Spy, Zeus, Carburp, using fake Facebook friend requests. I'll talk a little bit more about some of the stuff, and this is just kind of a timeline of a lot of events that happened in 2011. Some of them I just talked about. Early in the year, there was an ad server network that was compromised, and that was one of the first big stories I saw about black hole. And they also did a lot of SEO poisoning. They ended up releasing, I guess it ended up being 3 different versions of their kit in 2011. And there's also the mass WordPress compromise that was started in November, targeting it was a WordPress plugin called Tim Thumb. And there's a vulnerability where you could actually upload any kind of file and get it executed. And there was a patch release for this in August, and a large number of people running WordPress were not updating their, this plugin. And so then there was a mass compromise campaign launched by people running Black Hole, and they got hundreds of thousands of these WordPress blogs compromised and redirecting to Black Hole. And then, and so they've also been doing recently, and I just saw a paper last month from Trend Micro. They go into a lot of depth about the spam campaigns that Black Hole's been using, and I've been collecting quite a bit myself. And the reason they're using spam over trying to compromise the site is because it's a lot easier. It's easier to get a list of 1 million people and send out an email to them and try to get them to click on a link and try to find a popular enough website that has a vulnerability that you can exploit, or SQL injection, cross-site scripting, to get your stuff in there to redirect them. And the amount of spam that they're generating is significantly rising. And so a lot of these that I've seen have been like fake delivery notices for UPS and FedEx. And I saw a lot of that around the holidays. So it's definitely, they're also using contextual stuff like that. Fake IRS tax notices around tax time in April, which is for people not in the U.S., from the U.S. And then, just fake orders from Amazon, other places. So you go in there, you see this link saying, hey, click here to go see more info. You end up going to Black Hole site, and you end up getting owned. And so this is just some screenshots of the control panels that Black Hole uses. These I borrowed from Xylitol's blog. So he also does a lot of work on exploit kits, and he's really awesome. And a lot of this stuff, it's his information has helped out a lot. So up here you see, like on the upper right, you'll see like different exploit percentages. You'll see visitor browsers and the percent of exploit rates. You see countries visited. Then you'll see operating systems and just some general statistics that you can that they show. And so it's like what you'll see with this versus like Phoenix and some of the other kits is, they definitely have tried to create a much nicer look and feel than a lot of other kits in their control panel. And so on this kit, you'll actually see the top vulnerability was Java 2011 3544, Java Rhino, and it was a patch release late last year, and this was the first one that Black Hole actually got it was about a month after it was patched, and so it has an 83% success rate in the wild, which is crazy. And also the other interesting thing is that the most exploited operating system at that time was Windows 7, and so but then you look at all the others, and they're 10% for a PDF vulnerability, 3% and extremely low, and so it's like why is this vulnerable? And this actually seemed to start the trend where they added another Java exploit in early 2012, very soon after like a month after a patch was released. Then they just did the same thing again. And so I was trying to figure out why aren't people patching it? Why is it not being nearly, why is it being so successful? And so I love Reddit, and I was browsing Reddit, and I was browsing the rfunny subreddit, and basically the perfect image popped up, and because it was someone making fun of exactly this. What do they say, the Java update? Not today. And so it's just people ignoring, saying, oh, there's a Java update in the system tray? Nope, go away. And so I saw that, I laughed, and then I face palmed. So it was just kind of that thing that it perfectly exemplified the problem that we see in the wild. And so, so this is just another screenshot of the control panels where you can see different payloads loaded, how many times the payload has been loaded, and stuff, and there's a little bit more information. So now I'll actually get a little bit more into some of how it works. And so running all these things through our sandbox, we've looked a lot at URLs that it uses, redirects to where it loads its payloads. I actually found it's quite predictable at the moment, at least. A lot of times it's a PHP file. A lot of the time it's normally showthread.php, main.php, and then they normally have it normally has one URL parameter, and a lot of the times it's actually page equals, and then it's just like a 16-character hex string. And it's something that's very detectable, but it's like, I can look at your URL and say, I'm pretty sure that's Black Hole, but then it's also close enough to some real URLs to where it's like, you kind of get in that spot of, I can't just stop someone from visiting that because it could be a legitimate page, and I would end up getting yelled at if I did that. And so once that's loaded, and then it ends up redirecting to its malware payload, a lot of times it's normally, it's a one-letter PHP file. W.php is what I've observed a lot. T.php is also another common one. Normally has a couple URL parameters with this one too, and so it ends up being another thing that's very predictable, but it could easily block a lot of legitimate traffic. So it's like you have F and E as URL parameters, and the values are all within very small ranges. And so it's like that. It's like I can tell what you're doing, but I can't. It ends up becoming very hard to only block that. And so the JavaScript that Black Hole uses, it's their obfuscation techniques. They tweak them just a little bit. So it's like every time you go through and you're going through the obfuscation, it's like I can catch everything you're doing now, and then they tweak it just a little bit to where now you don't catch it. And so it's like they'll use character separators, or they'll do. I'll show an example of this in the next slide. They'll do, they'll have a text blob and a HTML element or a parameter. Sometimes they actually just have a giant URL of integers, and so they go through that. They pull this out. They'll actually do a split to turn their text blob into an array of integers if it's not already, and then they run it through a deobfuscation routine. that ends up, it includes many other common obfuscation techniques, like doing string from char codes on ints, using square bracket and quoted value to execute a function like Windows square bracket quote eval, or then sometimes they'll break it up so it's to like e plus v plus al, or they'll actually even assign one variable to half of it and then another to do that plus the other half of it. So it's very common stuff that we see a lot. But then so then the deobfuscation routine, it goes through it, once it actually gets to the meat where it's handling this giant text blob, splits it, and then it'll do a string from char code, and then it'll add or subtract an integer and end up building up a giant string that ends up running through. It's normally reassigned eval in JavaScript, and that's actually ends up being a malicious iframe that redirects to their site, and so then you end up getting the browser and plugin detection and launching and loading malware. So here's an actual sample. On the left, you actually will see deobfuscated JavaScript. On the right, you'll see the obfuscated JavaScript. And so, if you see this on a page where it says, please wait, page is loading, that's usually one of the indicators in deobfuscated JavaScript of, it's like you've just visited a site that's been infected by a black hole, and you should probably, really, get your computer scanned. But then over here you actually see the text blob I was talking about, and this one's a little bit different, where they use a semicolon period as their separator between their values. And then at the, let's see, I guess like up here you see string from char code. They're actually doing so you'll actually see right here that's a float value. Then they do a floor. They end up they do a lot of little tricks, but it's like you can open up a web page and look at this and you can say that's definitely malicious, but how do I, from our perspective as an inline device, how do I stop that before it gets to what's on the left and the when it's transformed in the browser? So it's definitely, it's like stay on top of stay on your toes, keep on top of everything, and it ends up being a very difficult problem. And so they also do a lot of PF exploits, but they use different obfuscation than they use in their JavaScript. So they do a lot of ASCII character replacement in PDFs because the PDF document parsers will actually just straight turn something like ampersand pound 00097 into an A, but they still will use either giant text blobs or raise events, and then they also they'll have multiple character separators, like 3 @ signs, but then they'll do an ASCII character replace for the first @ sign. They'll leave the middle @ sign in there, and then do another ASCII character replace on the last @ sign. So it's like another thing. It ends up being very recognizable, but trying to figure out a way to efficiently detect it in an automated fashion, inline becomes the difficult part. And once this gets through the deobfuscation routines, it ends up following very similar patterns that the JavaScript, the HTML JavaScript does. So it ends up having the same purpose. And so they also all their JavaScript shellcode that once you deobfuscate it, you can actually easily find it. They don't make an attempt to hide it, and but it also, a lot of it exhibits the same behavior. It's very easily detectable. You see the standard jump call patterns that you see in shellcode. They try to do a little bit of obfuscation where it's like you load it up, you don't see anything that looks decent. Like you can run strings on it, you won't see any URLs. But they actually do a simple XOR at the beginning of their shellcode, and then you end up at the end of it, you end up with like good assembly code that you can find a lot of strings in. You can find URLs. You can actually follow it, follow the path of execution, how it gains execution. So the image at the bottom is actually one of the URLs we found at the after we deobfuscated this, and ends up. And you run the shellcode through something like libemu, and it's easily detected. So they're definitely not on the forefront of like evading anything like that. So here's an example of I guess the left side is deobfuscated, and the right side is the obfuscated shellcode. And so there you actually see it's actually subtracting a negative number to get the number of bytes it wants to patch. And so that number of bytes ends up being positive. And right there, it's doing its XOR loop. And then that part on the right side actually ends up becoming what's on the left, which ends up being the valid assembly code where it actually does a bunch of jumps before it actually starts executing. And recently, they implemented a pseudo-random DNS generation algorithm. And where this actually makes it harder than something like, a recent example is Flashback. But Flashback actually, everything with Flashback use the same, DNS generation algorithm. It connects to the same servers. Whereas this is actually every instance of Black Hole has a slightly different generation algorithm. So and it changes every 12 hours, and it makes it a lot more difficult to catch every kit. Because before it's like, hey, I know their bulletproof host is this DNS name, I can block it. Now it changes every 12 hours. Now it changes every 12 hours for thousands of installs. So it makes it a lot more difficult. So at the bottom, you'll actually see it does a call to make frame, which then ends up doing a generate pseudo-random string. And on this one, it's using DNSstuff.com, which is a free dynamic DNS service. I've seen other instances of using just top-level .rus and other things. And so and then here it actually does a random number generator based off the time, and where it does if s is less than 12, then it's 0, otherwise it's 1. So that's actually where it's using to cycle the DNS name per day. And and here it actually, and then it ends up pulling out gets a color out of the string, and it generates, it uses its random number generator or pseudo-random number generator to grab 10 characters, and ends up being a color-10randomcharacters.dnsstuff.com domain name at the end of it. And so it's just they just recently added this. I think it was like near the end of last month. So it's they're definitely trying to add more things and keeping their place as the most popular kit. Next kit I'm going to talk about is Phoenix. And it's been around since 2007. It's pretty old. It's up to version 3. They do mini and full versions. And so it's like, the difference between mini and full isn't, they don't offer you more exploits. It's more of just like you can do multiple affiliates and not. They do things that I've seen other kits do they track if you visited the page once, and if you visited the page one time, then they don't actually launch the exploit again. Which, when I was first playing around with these kits, I was using like curl in the command line, and I was just like having an output straight to standard out. And then I'd try to hit it again, and I wouldn't be able to get it, and I'd be like, what happened? And it's because they're like, oh, we might have exploited you once already, so we don't want to try to exploit you again. Or we only want to serve the page up to you once to keep you from getting any more information than you can. And also because Phoenix is so old, it actually has quite a few exploits, but like mini kits, they're actually fairly old exploits. And so here you'll see some of the statistics that Phoenix uses. So this is their advanced statistics page where they give you a lot of information about browsers and a basic statistics page where you can see some exploit statistics and some more browser statistics. So it ends up being not nearly as interesting or as nice to look at. But the way Phoenix does JavaScript obfuscation is they tend to use multiple script tags, followed by a text area tag, followed by another script tag. And this all ends up being in a row. And so they'll actually end up pulling, in the text area tag, they actually have a couple of variable initializations that they pull out and then they execute in one of the other script tags. But then even after you deobfuscate, this code ends up being, it's not terribly obvious exactly what it's doing. And like with Black Hole, I saw a lot of references to things like git shellcode or heap spray, or just like if you can actually figure out a way to deobfuscate it, like on the fly as you're inspecting it, you can like, oh yeah, that's definitely malicious. With Phoenix, they don't quite follow the same patterns. And so this is what some of their obfuscated JavaScript looks like. At the top where the arrows are, you'll see the two script tags together. It actually ends up being much, much longer and not terribly interesting, but it's like one of the things you look at this and you're like, that's probably not going to do anything legitimate, but with a lot of the minifying of JavaScript, it ends up being much more difficult to not like detect false positives related to this. And so the PDF obfuscations that Phoenix uses, they resemble a lot of Black Hole's JavaScript obfuscations. And Phoenix was first, so it's likely that Black Hole definitely saw what they were doing at the time and decided to take it and improve upon it. And so they do the large array of integers, they run through a deobfuscation routine, then to launch the exploit. But the way they do deobfuscation is a little bit simpler than Black Hole. They're not doing any kind of math. You actually see that they use an array, they index into an array that's used to index into another array, and then they just loop over a hard-coded number of bytes. And so it ends up being, and then they do an eval reassignment at the end. So it ends up being, not terribly sophisticated, and it's kind of like another one of those things you're like, I can look at this, I can see it's bad, but then, how do I block this without blocking other legitimate things? So now I'll move on to some of the other exploit kits that have been coming out. And over in like late 2011, early 2012, it seems like it's a lot of people have witnessed how popular these kits are becoming, how much they've how successful they've been, and they wanted to get on the game. And there are lots and lots of new kits coming out. And we've actually been quite a few coming out from China. I'm going to talk about one of them and talk about some of the characteristics that it exhibits and other kits from China exhibit. And the interesting thing with that is a lot of the kits have been coming out from Eastern Europe and Russia. And so to come out from China actually ends up being like, interesting. It's just kind of a new wrinkle in the game. And they've also had a number of, and they also came out with a small number of exploits, but they're actually targeting more recent vulnerabilities than the other established kits. And so then we've also seen kits pop up and disappear, but overall it just ends up being a very large number of these things to keep up with, and because it's kind of like a startup where everyone has a great idea and a lot of people try to follow it, but then a lot of people fail. So they just kind of go away and you never see them again. So Yangpak was actually from China, and it first started seeing it in late 2011, early 2012. It was it's out of China. It only had 3 exploits in it, but they were actually targeting fairly recent vulnerabilities, but also had very low detection rates on VirusTotal. The other interesting about that is they're not using JavaScript obfuscation. They're not using like PHP and like MySQL or anything on the back end. It's just a static HTML file with everything hard-coded, and they still weren't getting detected. I mean, the detection rates were like less than 10% right after it came out. And so HackersSecurity, I mentioned earlier, he actually has quite a few more blogs about other kits from China, and I reference those in the white paper as well. The next kit is Sweet Orange, and this one was a kit that I haven't witnessed in the wild, that I haven't seen really anyone else except for Dancho Danchev talk about in one post on WebRoot. But I want to talk about it here because of basically they've actually managed to keep their kit out of researchers' hands and like very hidden. And so it's kind of a very hard question of, are they being successful with this kit, or are they just basically marketing fluff of saying, we're not going to even show you or demo this kit to you at all if you're not an established member of Underground and we don't feel like we trust you at all. They set a high price, especially for an exploit kit, $2,500, then renting it to you at $1,400. And none of the researchers I've talked to have seen this in the wild. But then again, we may easily have samples of it, we just haven't been able to tie it to this kit. And so these are some of the screenshots of Sweet Orange, and again, you see very similar to like Phoenix, where they just throw up their numbers. They're not trying to make it look nearly as nice as Black Hole. But you see country statistics, browser statistics. You'll see some browser version statistics as well, just general statistics. And it's just another screenshot of just their general control panel. These were also taken from Dancho's post. So the last kit I'll talk about is Nuclear Pack, which was actually one that it popped up and then it disappeared. And it didn't reappear until this year, but it only has 4 exploits with it. But the interesting thing about this one was they added an anti-honey client / web crawling feature into it, just to try to prevent people from collecting any information about their page, collecting their exploits by they actually use mouse movement as a sign of a human using the web browser. And so normal web crawlers not going to do that. Sandboxes are similar, honey clients as well. And so it's like really to detect it, you kind of need more interactive things to do it. And so this is actually their anti-crawling routine here, where they have a document on mouse move function assigned. They use a XYZ flag to for various purposes. And here you also see some ASCII character replacement type stuff. Then down here at the very end, it's like once you get a mouse move, then they'll end up creating a JavaScript tag that they end up appending to the head HTML element. So their JavaScript gets loaded, the exploits gets launched, and they hope that they compromise you. So in conclusion, the exploit kits are getting more sophisticated in terms of adding newer exploits and more recent exploits and trying to do more evasions and obfuscations. And a lot of the reason they're doing this is because they're a business, and the guys who write these kits are trying to make money, and they're trying to protect their business model, and they're definitely wanting to figure out ways to keep making more money. But they're not sophisticated in the sense of like the unfortunately I have to use this term, APT attacks, that are trying to stay under the radar and silently exfiltrate data. These guys are just trying to get past the first level of detection to infect the computer and add it to a botnet, and then figure out ways to make money. And so detecting the ways that they're adding techniques and the ways that they're doing stuff takes a lot of work, and it takes constant work. And there are a lot of recent mitigations that web browsers are trying to add, like blacklisting plugins if they detect them to be out of date, and also you also see things like Flash adding in silent update features. Firefox has been looking at adding that in. Chrome does it. So it's they're definitely combating these guys and trying to combat them in many ways. And it'll be interesting from my perspective to see how they end up, how the exploit kit authors react to these things, because they're definitely going to react, but I don't expect them to react with 0 days, because they don't need to use 0 days, because what they're doing works, and it's going to keep working as long as people don't patch, and as long as we can't make people patch. So I just want to give thanks to a couple of people I work with, Mark Eisenbarth and Joanna Berkey, and the rest of the DB Labs people. They've definitely been great for support and ideas, and some ex-coworkers, Alan Pusick, who actually turned me on to this stuff originally, and a lot of the researcher communities. I've probably forgotten some people, but Jorge Mears and Malware Int, and you can see the rest up there. So thank you, and if you have questions.
So one question. So I want to know how many exploit based on ROP-based techniques?
Can you repeat the question, please?
So how many exploit based on ROP written to original programming, these kinds of techniques?
I haven't done a lot of the exploit, like deep analysis on the actual exploits and how they work themselves, so I don't have a whole lot of information on that, unfortunately. So, thank you.